Alright, here we are on practice 1.3.1 for Math 1. So we're going to graph some equations, okay? Some linear equations. So the first couple, it just has us graph them. So we've got y equals x plus 2. What we should notice is that this is in that slope-intercept form, mx plus b. Or as we learned in class, it's x sub 1 over y sub 1 times the x plus the b. And remember, those letters each stand in for numbers, except for this y and this x. Okay, and when we're dealing with a coordinate plane like this, the horizontal is our x-axis, the vertical is our y. That's what this x stands for, this x, and this y stands for this y. These ones up here, or the m is this whole thing, not separated. Okay, they'll have numbers in there. Same with b. So y equals x plus 2. Well, that x could be like 1, and we could make it a fraction. So it'd be like 1 over 1x plus 2. Now, the b, or the number without the x, the starting point, not the growth, okay, that number goes on the y-axis, and that's our starting point. Okay, then these two numbers, or and I did it backwards, that's y over x, isn't it? Okay, the y tells us vertically how we move. The x, the one on the bottom, tells us horizontally how we move. So 1 would mean we move up, so from here we jump up here. But then this bottom x would mean that we move to the right one as well. So we'd have that. And we'd keep going in that pattern, up 1 to the right one. Now that pattern continues both ways, so it could also work going down into the left one. Okay, the exact opposite. And we can draw our line to match. Well, that was a horrible line. We can draw our line to try to match those points. And there's our first equation. Okay, so it's the same idea on pretty much all of these. So for the next one, we go 1/3 x plus 2. So the 2 is where we start. That's our y-intercept. Okay, where x equals 0. And then we go, the 1 is the horizontal or vertical, so we go up 1, the 3 to the right 3. Or we could go down 1 and to the left 3. So it was y equals 1/3 x plus 2 again. So we go up here to 2 to start, then we go up 1, right? Up 1, and at the same time we go to the right 3, so up 1 to the right, 1, 2, 3, to draw our next point. So up 1 to the right, up 1 to the right, 1, 2, 3. Okay, now typically we only need about 3 points. We could keep going, we could go down 1 to the left 3, but with that it's enough to draw our line and to call it good. Okay, so there's our second graph. And in your workbook you have some graph paper too that you can use. Okay. Alright, so now let's make some equations and then graph them. So a gear, and I guess really quick to talk about that. When we make a table, okay, those same numbers, that y equals y sub 1 over x sub 1 plus x plus b, that x sub 1 is how we see that x value growth. The y sub 1 is how we see that y value growth, what we're adding by. So this x sub 1 in our table, we'd be adding 1 each time, right? Plus 1, plus 1, plus 1. The y would depend on our situation. And the b comes from wherever the x equals 0. Whatever number's right there is going to be our b, our starting number. Okay, so let's look at 3. So a gear on a machine turns at a rate of 2 revolutions per second. Let x be time in seconds, so 0, 1, 2, 3. And y number of revolutions. What is the equation that models the number of revolutions over time? Graph that equation. So, before we start moving it, okay, that would be 0. Then, it's moving 2 revolutions every second. So, when we go to 1 second, we'd be at 2. Then at 2 seconds, we would have done 4. At 3 seconds, we would have done 6. So, our y growth, we're adding 2 each time. So, our equation would look like y equals our y growth, 2, and positive because it's plus, over our x growth, 1, positive because it's 1, times x, plus, where did we start? We started at 0. Okay? Not because it's the first one in the table, but because it's across from the x being 0. Now, adding 0 doesn't do anything, so we get rid of it. And we can graph that. We can also simplify that to be y equals 2x. Same thing. So, y equals 2 over 1x. So we start at 0 on the y-axis. Then we're going to go up 2 to the right 1. So we count. Up 2, 1, 2 to the right 1, right there. Then up 2, 1, 2 to the right 1, right there. And we can keep following that pattern, or I can call that good and draw my line. Now, here's the problem. Okay, can we, according to our story problem, can I draw to the left? Because what does x stand for? It stood for time. So if I draw to the left of that, that's going to be negative time, which you can't have. So technically, I should start my graph at that 0. Then, do we draw the line? Well, think about this. If I stopped my revolutions in between 0 and 1, would it have still moved? Yeah. So it's continuously spinning, right? It's continuously spinning, so I can draw a straight line, and then that arrow tells me it just keeps going on. Okay? So there are some other aspects when we deal with a story problem, a contextual problem, that we have to figure in. Okay? Alright, let's look at number 4 now. Okay, so the relationship between degrees Celsius and degrees Fahrenheit is linear. To convert a temperature in degrees Celsius to degrees Fahrenheit, multiply the temperature by a rate of 9/5 and add 32. What is the equation that models the conversion from degrees Celsius to degrees Fahrenheit? Graph this equation. Alright, so the idea here, this is kind of a tricky one too. So, it says multiply the temperature by a rate of 9/5. So, if I went from 30 degrees, I would have to multiply it by 9 over 5, which is 9/5. If I went to 31 degrees, okay, I'm changing it slightly. Maybe that's not the best way to go about this. Okay, but the idea is here that 32 is like our starting point. Okay, 32, and then we're going to add 9/5 for every time our temperature changes. So it'd be 9/5 x. Okay, so that's what the model would look like, or we can rearrange it to be 9/5 plus 32. Okay, equals y. So to graph that, 32 would be our b, our y-intercept. This would be our y change. This would be our x change. Okay, so it's a positive 9, so we're going to go up 9. It's a positive 5, so we're going to go to the right 5. And we're going to start at 32. Now, looking at my graph, it's not going to go clear up to 32, is it? So, we would, have to kind of estimate here and count by a certain amount. So maybe by every, count by 10s here, count by 5s here. Oh, that would be 40 and 50. So 32 would be right about there. And then I'm going up 9 every 5. So I go up 9. 10 would be right there, so slightly lower. And then over, oops. Here, let's do it this way. So 10 would be a full-on jump, because each one of these tick marks stands for 10. So it'd be not quite 10, and then over 5. So it'd be about right there. Then we jump up 9. So 41 plus 9 would give us 50 to the right 5. It'd look like that. Now once again, we can't go to the left, but we can have temperatures in between, so we draw our line like that. Okay? Alright. Okay? That one was tough because of the way the thing is set up, but let's try the next one. Actually, let's delete this first, right? Alright, that one was a difficult one to do though. Okay, so now 5. This one hopefully will be easier. A cab company charges an initial rate of $2.50 for a ride plus 40 cents for each mile driven. What is the equation that models the total fee for using the cab company? Okay, so a table would be a great way to start. So we've got miles driven and cost. cost. Okay, or X and Y. So if we just get a cab and we don't go anywhere, that would be $2.50. Okay, so then every mile we're going to add 40. Okay, so we'd add 40, so that'd be $2.90, then $3.30, then $3.70, and so on. So our x is growing, our x1 is growing by adding 1. So it'd be y equals, fraction x1 would be 1 on the bottom, and here we'd be adding 40. Okay, a positive 0.40 times x. Now, anything over 1 is itself, so why don't we just get rid of that fraction and make it 0.40 x. And then where did we start? We started at positive 250. Okay, so here again, looking at this, 250 would put us about right here, 2.5. Okay, that's where we started. That was our y-intercept. Then we're going 40 over 1, so every time we go to the right one, we're only going up 40 cents. So not quite 50. So to the right one, up about 40 cents. To the right one, up about 40 cents. Okay, and we'd follow that same pattern. So we draw our graph. It's going to keep going the more miles we do. We can't do negative miles, so we wouldn't be going less than that. So there's our graph. Okay, so that 40 cent is seen right there. The 1 mile is seen right there. And a 250 in the equation is right there. Okay? Alright, number 6. Matthew receives a base weekly salary of $300 plus a commission of $50 for each vacuum he sells. What is the equation of the model to models his weekly earnings? So we have weekly and earnings, or X and Y, since we're putting them on a graph. Okay? So he earns $300 just for working, base salary. And then every time he sells a vacuum, so I guess this really isn't weekly, is it? It's vacuums, how many vacuums he sells. So if he sells a vacuum, he'd add $50, so it'd be $350. 2, he'd add 50, 400. 3, and so on. So this one is growing by adding 50 for every one vacuum that he sells. So the equation would be, I guess we can do it right here, y equals 50 over 1 times x, because that's our growth, plus where did he start? He starts at 300. Okay, so looking at our graph, we've got y equals 50 over 1x, which we normally would just write y equals 50x, same thing, plus 300. So maybe we should count by 50s on the y, and on the x count by 1s. So 50, 100, 150, 200, 250, 300, 350, 400, 450. So we'd start at 300, and then every time we sell a vacuum, every time we go to the right one, we get $50 more. To the right one, $50 more, and so on. So our equation would look like that, graphed. Okay. Now, if we were just basing it off the equation without the story problem, we draw our graph going the other way. But because we're dealing with story problems, we actually need to make sure that we follow through with that. Of course, probably did this one wrong, didn't I? Okay. Should we connect the dots here? Can he sell half a vacuum? No, so really, we shouldn't connect our dots, because he can't sell 2.5 vacuums and get paid $375. Doesn't work that way. Okay? So, according to the story problem, we do need to think about whether we can connect the dots, because we can't always connect the dots. Okay, number 7. We're almost there. A water company charges a monthly fee of $6.70 plus a usage fee of $2.60 per 1,000 gallons used. What is the equation that models the water company's total fees? Graph this equation. So we start out at 670, right? So we go y equals 670. I'm trying to do this one without a table. We have a usage fee of $2.60 per 1,000 gallons used. So the first 1,000 gallons we'd add $2.60. The second we'd add $2.60 again. Then we'd keep adding $2.60, right? Well, how do we shortchange that? Multiplication. Do we know how many gallons we'll use? No, so we use the x. Now, is this exactly the same as everything else? Yeah, we can rearrange it because it's addition. So 260x plus 670, same idea. Could we make it into that fraction? Yes. So our x sub 1 would be the 1, so horizontal growth is going to go 1 at a time. Vertical growth would be the top, the y sub 1, so we'd go up by 260 every time, and we start at 6.7. So 6.7 would be about right there, past that, about 6.7. Then we're going to go up $2 to the right 1, $2.60 to the right 1. And we'd keep going in that direction to get it done. But I kind of ran out of space, didn't I? Here, let's scoot it down. So we start at 670, so 1, 2, 3, 4, 5, 6, 70. We're going up 260, so we'd go up 1, 2, and some, so it'd be like up over here to the right 1. So we go up like same space to the right 1, okay, and so on. Hopefully your graph will be a little bit bigger and you can do that. Okay. Alright. Let's go back. Number 8. Okay, Maddie borrowed $1,250 from a friend to buy a new TV. Her friend doesn't charge any interest, and Maddie makes $40 payments each month. What is the equation that models the money Maddie owes? So here we start out with $1,250, right? That's how much she owes. Then every month she's paying $40 back. So from that total she'd be subtracting 40, right? So that would be 1210. Subtract 40 would be 1170, then 1130, and so on. So we're going down 40 for every month. Okay. So if we look at our graph here, maybe you'd want to extend this. Count by 100, 100, 200, 300, 400, 500, 600, 700, 800, 900, 1,000, 1,100, 12,000, 13,000. So our equation would be that starting point and our growth. Our growth, we are subtracting 40 for every one. So it would be y equals negative 40, because we're subtracting it, over 1x plus 1250. So y equals negative 40x plus 1250. So 1250 is right here. Subtracting 40 as we go to the right one would be about here, then about here, then about here. We just keep going down 40 as we go to the right one. Okay? Then, could we draw a line? Well, maybe she pays it like $1 a day or something, so maybe we could. Maybe she pays it at the end of the month. We're not sure, so let's just draw the line. Okay? Alright, number 9. So, a company starts with 3 employees and after 8 months grew to 19. The growth was steady. What is the equation that models this growth? So, draw a table to help us. So we started with 3, and after 8 months, we grew to 19. Okay, so how are we going to figure this out? Well, you could go 19 minus 3. That would give us 16. Okay, so 16, how much would we have to add to go 1, 2, 3, 4, 5, 6, 7, 8? So that would be 8 things. So we'd be adding, so here's a cool mathematical way. So it'd be 8, and we're adding the same thing over and over. That's our multiplication, right? So if we divide by 8, we end up with 2. So we're adding 2 each time. That's kind of a cool trick you can use when you're not given. So 5, 7, 9, 11, 13, 15, 17, and 19. So for our equation, we find our starting point where the x was 0, y is 3. So y would equal 3. We added 2 to it each time. How many times? We're just going to keep adding, so we'd hit x. Now, can we rewrite that, can't speak here, as 2x plus 3? Yeah, both of them are the same. Okay. if I left it as y equals 3 plus 2x, then I'd say, where do I start? I start at 3. There's 3. What's my slope? How is it changing? The vertical is going up by 2. The horizontal is going over by 1. So up 2 to the right 1, up 2 to the right 1. And I just go like this, right? Up 2 to the right 1, up 2 to the right 1, or to the right 1 and up 2. Okay? Then we decide, do I fill it in? Well, you can't have partial people, so I'd probably leave it dotted like that. Alright, are we on to the last one now? Okay, last one here. You and some friends are hiking the Appalachian Trail. You start out with 70 pounds of food for the group and eat about 8 pounds each day. What is the equation that models the food you have left? Okay, so think about that table again. So we started out at 70, so we know we're going to go y equals 70, and we eat 8 pounds a day, so we're subtracting 8. So after 1 day, we'd be down to 62. Subtract 8, and it'd be down to 56. Subtract 8, it'd be down to 48. Subtract 8, be down to 40 after 4 days. So we're subtracting 8. That's our growth here. We're going up by 1 here, and so that's where the x goes. So in other words, we could go y equals negative 8 over 1 x plus 70, or y equals negative 8x plus 70, or y equals 70 minus 8x. It's all the same. Okay, so we go up to 70. Maybe we count by tens. There's 50. That was 90. So here's 70. Here's where we start. And then we're going down 8 each time. So we go down 8, which these stand for 10, so almost the whole way to the right one. Down 8 to the right one. Down 8 to the right one. And we just keep going like that. And we could draw our graph. Just like that. Alright? So there we go. Hopefully those were a few different ways to show you how to do that.